Hey guys, welcome to Wassermen Lounge today, and I'm going to be showing you a basic chemistry tutorial on matter. So basically, matter is defined as anything that occupies space and has a mass. Mass is the quantity or quantitative value, which is basically something that can be described in numbers, whereas quality is like a trait of something. Basically, mass is the quantity of a matter that a substance possesses, and depending on the gravitational force acting on it, it has unit of weight assigned to it. The weight can vary, of course, but the mass of the body is constant and can be measured by resistance to a change of position or motion, otherwise known as inertia, by the way. And since matter occupies space, we can compare the masses of various substances that occupy a particular unit volume. Basically, this is shown in the formula D is equal to M over V. And in the next slide, it's this, basically. So you have density is mass divided by volume, right? And basically, the basic unit of mass in chemistry is the gram. And the basic unit of volume is the cubic centimeter, or otherwise known as milliliter. Well, so how does density vary? Well, an example is in 1 gram of gold. This is not a gram of gold, this is 1,000 grams of gold. But in 1 gram of gold and in 1 gram of styrofoam, let's say, both have the same mass. That is 1 gram. They have the same mass because the mass is equal to 1 gram. However, the volume occupied by styrofoam is much larger. Therefore, the density of the metal is larger. Because, let's say, this is just like random number, right? Let's say it's 1 gram for styrofoam, let's label it S, it divided by, let's say it has a density of 5 ml. I'm just guessing. No idea. That's way too high anyway. And it has a greater, a greater volume. But in gold, you have 1 gram, but the volume is going to be so much less. It's going to be 3. Let's just say 3. That's way too high again for 1 gram of each, but let's just random numbers. So basically, that's the density of a metal is like higher than that of styrofoam. Well, when you're dealing with gases, basically, for density is grams per liter at standard temperature and pressure. That's just for gases, and the aspect of density in gases will be discussed in a further video. Well, now, what are the 3 stages of matter? Matter has a gas stage, a liquid stage, and a solid stage. So a solid can be distinguished by a definite size. That means a constant size and shape. It won't change. Shape and size will not change. Liquid, on the other hand, has it takes the shape of a container. So we can see that you have this container here. It's taking the shape of it, right? And it basically has a definite volume or a constant volume and takes the shape of a container. While a gas has neither. It does not take the shape of a container, or does not have a definite volume. So, and you can change from one state to another through adding of heat. So if you add heat to a solid, for example ice, it melts into water, which is a liquid. Then, if you heat it up enough, which is like the boiling point of water, it's going to turn into gas, otherwise known as water vapor. So, now let's look at the composition of matter. Well, matter is divided into 2 general categories: distinct substances or pure substances, and mixtures. How do you know which one is which? Well, it's a physical method. Basically, can you separate the individual components Can you or can you not? So that's basically it. Can it be separated? If no, oh wait, sorry. Sorry about that. If yes, it's a mixture. If no, it's a um, it's a distinct substance. Now, basically, in mixtures, you're gonna have two types. If the composition is uniform, so if you have the same uniform, you're gonna have a homogeneous mixture, like granite, not granite, air, sugar, and water, or stainless steel. If you have if the composition is not uniform, if what makes the mixture is not uniform, you're gonna have a heterogeneous mixture. Granite, wood, blood. It's made up of multiple things. Now, what's the other side? The other side is pure substances. So when you go back to can it be separated? No, it cannot. Now this the definition for pure substances is kind of weird, or the distinguishment. So can it be decomposed by ordinary chemical means? If yes, it's a compound. If no, it's an element. A compound would be like water, sodium chloride, sucrose, elements like gold, chlorine, oxygen, tin, basically just or element, sorry, is gold, chlorine, oxygen, yeah, and tin. So that's basically an element. Now, so let's just go over it one more time. So distinct substances, elements. Composition is made up of one kind of atom, and all parts are the same throughout. Compounds. Composition is definite. It's homogeneous. So basically, like water or carbon dioxide, all parts react the same, and the properties of the compounds are distinct and different from the properties of the individual elements that are combined to make it. So let's go over two, and then let's just go over mixtures really quickly. So if compound is indefinite, generally heterogeneous, it's like marble. Properties of the constituents are retained. So basically, each is the components of the mixture. Let's say this is like a rock and sand, and this is, I don't know, like a piece of glass. They're gonna stay the same, right? It's not gonna change. And then the parts of the mixtures react differently to the change conditions. And so let's go over the law of definite composition, which means that compounds are made basically through the combining of elements in a definite proportion or ratio by mass, and are made up of two kinds of atoms. So the chemical formula for carbon dioxide is going to remain CO2 no matter what. You have a combined ratio of 2 to 1, no matter what type of carbon dioxide or where carbon dioxide is. It's just going to be the same. And a molecule of a compound is the smallest natural occurring unit of a compound, and it has a definite shape that is determined by how atoms are bonded or how they are combined with each other. So like double bond or triple bond or that kind of stuff. We'll go over that in another video as well. So, and elements, by the way, are made up of atoms. Well, everything is made up of atoms, but the most basic unit of an element is an atom. Same with compounds, heterogeneous mixtures and homogeneous mixtures, but an atom comes from Greek and means the smallest possible piece of something. And each element has its own unique atom. So, and let's also go over the law of conservation of mass. And that's basically saying that mass cannot be created or destroyed. It's probably one of the most, or matter cannot be created or destroyed, sorry. And it's a really famous thing. Most people know it before they take chemistry or any other science class. And so now let's go over physical properties and physical and chemical properties, as well as physical and chemical changes. So physical properties of matter are those properties that can usually be observed with our senses. They include like some common examples are physical state, like gas to liquid, or solid to a gas, or solid to a liquid. Color, odor, solubility in water, which means can it dissolve in water or can it not. Density, melting point, taste, boiling point, and hardness. Those are the general physical properties, those are the ones you should remember, as they will definitely come in handy. And then the chemical properties are the ones that you cannot, that can only be observed when a substance reacts or does not react to another substance. For example, iron rusting right here. So you have iron, and that's going to be rusting due to the moist air surrounding it, and it's going to cause the iron to rust. That's a chemical property. Gold, on the other hand, does not rust. That's a chemical property. Well, now what are chemical and physical changes? Basically, a physical change alters the physical properties of matter. So let's say, most often physical altered properties or physical changes are form. So your form and state. Sorry for the really bad handwriting, but anyway, form and state. Breaking glass, cutting wood, melting ice, magnetizing a piece of metal, all physical changes. Now, what are chemical changes? Chemical changes are changes in the composition and structure of a substance. They're always accompanied by energy changes. We'll go into more energy changes in the next video, which will cover energy, but basically, it's just a change in the composition and structure of a substance. So, it's like you have to heat paper before it burns. And burning is a very common chemical change, like causing fire. And yeah, that's basically matter. So you guys just need to remember density, mass, or volume. Matter is just anything that occupies space and has mass. State of matter, solid, liquid, gas, pretty easy. Physical, chemical changes, chemical and physical changes, and then the two types of matter and their subgroups. So thank you guys for watching. If you have any comments, feel free to message me or leave them down in the comment section below. And I'll see you guys for the next time. Peace.